So in this problem, you have a conveyor belt given to be right here, right? It has some height, and we have some giraffes. We'll go ahead and draw a giraffe. A little smiley face. Oh, little eye right there. All right, falling into a box that's below it. So it's falling like this into a box. So we read it carefully. If the box is 0.6 meters below the level of the conveyor belt, so right here, all of this information. Notice I have the units meters, so I know I'm dealing with some displacement, and it says below the level of the conveyor belt. So now it's telling me the height of the conveyor belt is going to be 0.60 meters. But since in this problem I'm going to let this point be the origin, so this is going to be my 0, 0 coordinate. That means if the giraffe falls below the origin, this value is going to be negative then. Continuing on, it says it's 0.4 meters away from it. So the box is 0.4 meters away from the conveyor belt. So it means this distance or displacement right here is going to be 0.40 meters. And it's going to be positive because it's on the right side of my origin. So my first two givens will be displacement x direction, which is going to be plus 0.40 meters. And my displacement in the y direction, which is negative 0.60 meters then. Continuing on, what must be the horizontal velocity of the giraffes as they leave the conveyor belt? Well, it's asking me for velocity, so I know the variable is going to be v. And since this is the velocity that leaves the conveyor belt, this is going to be my initial velocity. And since it says horizontal, that means it's going to be referred to the x direction. So my unknown here is the initial velocity in the x direction then. Now in this problem there are at least two more givens that it doesn't state in the problem itself. First thing you should note is the acceleration in the x direction is 0 meters per second square. Because this is a projectile motion, the only force that acts on the giraffe as it moves through the air is gravity. And gravity acts on it downward, not horizontally. So this is why this is 0. And for the y direction, as I mentioned earlier, gravity pulls it down with an acceleration of negative 9.8 meters per second squared then. And notice another given for y, since it's falling off horizontally, there is no initial velocity in the y direction then. So this is going to be 0 meters per second then. Okay, now to solve for this problem, we're going to have to use an equation with the initial velocity in x. So it means I'm not going to be dealing with the y right now. Now looking through this, I need initial velocity in x. So this equation has it, this equation has it, this equation has it, and this equation has it. So the next variable I need displacement. So this equation has it. This equation does not have displacement, so I'll cross this out. This equation has it, and this equation has it. And notice I need acceleration. So this equation does not have acceleration. This equation does, and this equation does. Now you might notice that there's a slight issue here. In the third equation, we need time. And in this fourth equation, we need final velocity then. So it looks like we lack information to solve this problem then. So we have to either figure out the time or the final velocity in x. Fortunately, you can use the y direction to solve for time. I won't be able to use the y direction to solve for the final velocity, so this equation will actually be useless to us. So the equation we're going to use is actually this third equation here. And we're going to change the problem. Now we have a new unknown that we need to find. We need to find what is the time. So now we're going to solve for a new unknown, time. And we're going to find time using the y direction. So we could ignore the equations for x because we won't need them in our case. So first thing we're going to look at is for time. So first equation, time's right here, time's right here, time is right here, This fourth equation does not have time, so I'll cross that one out. I'll go on to the next variable, y displacement. Y displacement is right here. This equation does not have y displacement, so I'll cross that one out. Y displacement is right here then. Next, I need acceleration. It's not in this equation, so I'll cross that one out. Acceleration's right here. And just to double check, I need the initial velocity in y, and this equation has it right here. So looks like we're going to use this third equation to get the time that we need to plug in to solve for the initial velocity in x then. So continuing on, we know we're going to use this equation right here. Displacement is equal to velocity in the y direction times time plus 1/2 acceleration times time squared. Now remember, one of our givens in the y direction, the initial velocity, is 0 meters per second. That helps us out because this term right here is automatically crossed out. So I'm left with this. Displacement is equal to 1/2 times acceleration times time squared. I'm going to go ahead and solve for time to isolate it. So I'm going to multiply both sides by 2. This 1/2, this 2 cross out. So I'm left with 2 times displacement equals to acceleration times square. Next, I'm going to divide both sides by acceleration. These two accelerations cross out. I'm left with 2 times displacement over acceleration equals time square. And then to get rid of the square, I'm going to square root both sides. So I'm left with time is equal to the square root of 2 times displacement over acceleration. So I'll go ahead and rewrite the equation one more time. 2 times displacement over acceleration is equal to time. I'll go ahead and plug in my values. 2 times a negative 0.6 meters all over negative 9.8 equals to time. Now I'm going to go ahead and jump to the next step. If you take 2 times 0.6 divided by negative 9.8, you should get the square root of 0.1224, and then you take the square root of that answer, you should get 0.3499 equals to time. And remember, when you take the square root, you get a positive or negative. But because time is always going to be positive, I'm going to drop the negative number. So I'm going to get plus 3499 seconds is equal to time. With the time we found, we could go ahead and solve for the initial velocity in the x direction. So we're going to be working with the x direction, so I won't need these 4 kinematic equations because they're dealing in the y direction, so I'll go ahead and eliminate them. And so I'll go ahead and eliminate the kinematic equations. First, I have to see which equation has initial velocity in the x direction. And it turns out that all 4 kinematic equations has initial velocity in x direction. I'll go ahead and look for displacement then. So displacement is here. This equation does not have displacement, so I'll go ahead and eliminate that. This equation has displacement here. This equation has displacement right here then. Next, I'm looking for acceleration. This equation does not have acceleration, so I'll go ahead and eliminate this. This equation has acceleration right here, and this equation has acceleration right here. Last, I need the equation with time in it. Well, this equation has time. This equation does not have time, so I'll eliminate this equation. And so for this part, I'm going ahead and use the third equation then. So using the third equation, x displacement is equal to initial velocity in x direction times time plus 1/2 acceleration times time squared. Well, remember, the acceleration in the x direction was 0 meters per second squared. That means that this term right here will become 0 once you insert the 0 into the acceleration. So this term basically drops out. So you're just left with this then. Displacement is equal to initial velocity in x direction times time. And since velocity is the variable that we need, we'll go ahead and solve for it. I'm going to divide both sides by time. That way this time and this time will cross out, and you're just left with displacement over time is equal to initial velocity in the x direction then. So using the equation that I found from the last slide, I have my displacement over time is equal to initial velocity in the x direction. I'll go ahead and plug in my values. I have 0.40 all over 0.3499. Dividing those two numbers, I get 1.143. Now, since this is my velocity, I have to remember to add my units. 1.143 meters per second equals to initial velocity in the x direction then. Now I'm going to double check my answer. So the answer I got was initial velocity is equal to positive 1.143 meters per second. My velocity should be positive since it's going in toward the right, and that the value is not too small. It's not like 0.1 or 0.2. It's not too big for a giraffe falling off a conveyor belt. So my answer does check out then.